Hello and welcome to the Akrometrix Introduction to Part Tracking. Part Tracking is a powerful new software feature available with the 6.0 release of the Studio software platform. All customers currently under Studio software maintenance will be eligible for this new enhancement. This two-part video will cover the basic concepts and benefits of the part tracking feature, followed by an introduction to how part tracking is used. Individuals watching this video should already have some basic knowledge of Akrometrix thermarray equipment and software. If this doesn't sound like you, then don't worry. You can contact your local Akrometrix representative and they will be happy to provide some more information about Akrometrix products and software. We will first cover the basic concepts and benefits of the part tracking feature. Part tracking, sometimes just called part tracker, was first designed around the concept of a microelectronics industry moving toward high-volume thermal surface characterization. The continuing trend is that Akrometrix customers want to do more and more testing. Not only does this take more testing time, but also processing time, and all the while customers want to maintain both accurate and repeatable surface measurements. The part tracking feature is built directly into the Studio software to work seamlessly with the surface measurement and thermal profiler software. The intelligence behind the part tracking feature is based on edge recognition technology. So as you can see here, instead of a user defining part locations and rotations, part tracking locates parts in space for each surface measurement taken and crops out each found part down to a cropped region of interest. This tracking continues through thermal profiling. To show some of the value added in the part tracking tool, let's compare a typical test case with and without using part tracking. This begins with test setup. Parts are placed within the camera field of view and very carefully line up with the camera orientation. If orientation is off, then parts have to be individually rotated in post-processing steps. Once a thermal run is completed, part locations are partitioned individually in the software. Ideally, the samples will not move during the thermal run, but realistically, this is rarely the case. When samples do move, then the user must either spend significant extra time in partitioning each image individually or accept that the chosen region of interest may likely vary over the temperature profile. Either way, the ability to partition a consistent region of interest can be a concern. Now let's look at testing these same samples with part tracking enabled. Watch this. Setup time goes from possibly tedious to very easy. You probably wouldn't just throw samples into your system, but with part tracking you actually could. Here we've located, partitioned, and can save both the phase data and displacement data immediately. Data partitioning is not required at all. What about the part movement during the thermal profile? Well, part tracking takes care of this for you by shifting the region of interest around with the part. Not only does this save time, but it gives a very strong boost to reproducibility. Akrometrix customers are often trying to correlate data between different equipment, locations, and companies. The biggest variation in these data sets comes from differences in the area that is cropped. Now, different users and companies can all be cropping the same data set automatically with part tracking. Part tracking improvements to reproducibility, setup time, and system throughput will likely change many companies' approach to thermal surface characterization as well as increase the value of studio-capable equipment. In the previous examples we showed processing of 6 samples, a reasonable test case with the Studio software. However, imagine the benefits of the part tracking technology of trying to test 50 samples at once. This is not only possible but straightforward with part tracking. Now in part 2 of this video we will go over the basics of how part tracking is used. This section covers the basic workflow and choices that will need to be made in using the part tracking feature. First of all, the software functionality is effectively unchanged until part tracking is enabled. Here we can set a region of interest and take measurement to get warpage results, no problem. The same applies for thermal profiler. So now we are going to bring up the new part tracking window and click to enable part tracking. We are now in part tracking mode. You'll notice that the enable disable button turns from red to green and also the previously green region of interest turns blue, which is now what we call a search area in part tracking. This is the area that part tracking will search for parts. So let's look at the part tracking window here on the left more closely. The first field is the image rectangle size, which is the size in pixels of the parts you wish to find with the current lens setup. Here you will find some part tracking search setting that can be adjusted as needed. This includes the number of instances so the user can specify a specific number of parts to be found or just find everything within the search area. The rotation and scale tolerance are used to specify if rotated parts or parts that are found with minor differences in pixel dimensions or scale are included in the found parts. The minimum match describes the percentage of edges that need to be found in order to determine a part is present. This typically has a large usable range, but too high and the parts may not be found, and too low and the user may get extra ghost parts in the data set. Outside of the search settings, the inset function will automatically crop found parts down to a smaller region of interest. This function will be used in most cases as typical test areas do not include the very edge of the part. Also, the increased contrast function alters the found light range of the image. So let's go through a typical test setup. We will first specify the size of the part we are tracking by assigning a rectangle model. This function will update both the rectangle pixel size listed as well as the model image shown here in white. Once we have the rectangle size, the search area can be dragged to include all the parts we want to find. Now we can go through and specify some search settings. In this case, we know to look for 4 parts. Rotation and scale are quickly set to a maximum rotation of 30 degrees and a maximum scale of 10% from the rectangle size. We'll leave minimum match at 65%, but add a pixel inset of 4 pixels. Now coming back to our camera window and performing an acquisition, we will get a new output results window made for the part tracking mode. This includes a part picker interface on the right to specify which part you wish to see data for at the time, as well as tabs that include surface, phase, and displacement plots for each part found. Additionally, if you aren't concerned with the surface measurement results and just want to check the part tracking results, choosing track parts will show the found parts without displaying the measurement results window. With the samples and part tracking settings set up, a thermal profile can now be run. You will notice a few changes in the Profile Setup window in Thermal Profiler. With part tracking enabled, a few more options are available, namely naming options for the found parts and how to organize the results into folders. Remember, with part tracking, users may have huge amounts of data out of a single thermal run without even using the surface analysis tool. Upon beginning a thermal profile with part tracking enabled, the software will first check for the number of parts found and confirm that this is the quantity the user intended to find. This quantity will be used throughout the profile so that the numbering of the parts will be consistent even if a part disappeared from the camera window. The bottom left and right windows work similar to the output window and surface measurement, where each found part can be selected on the right and results shown on the left. As highlighted earlier in this video, part tracking easily handles samples that move slightly during the thermal profile, always cropping out of the same data relative to the part. Let's take a quick look at just a few output files in a Windows folder. These files are from 6 tracked parts over 3 temperature points, and they include the 3D surface plots for each found part and temperature, phase images for each found part and temperature, and a full field image for each temperature. The full field images are saved to act as a backup in case for some reason a part is not found in part tracking. In this case, the full field is always available to partition a region, just as users were accustomed to before this release. Again, the benefits of part tracking as shown in this video can be broken down into dramatic increases in user productivity and sample testing throughput for the Akrometrix Studio system, along with the ability to get a highly reproducible region of interest. Anyone intending to operate an Akrometrix Studio system should now watch the part tracking user training video to best understand how to use part tracking. Thanks for listening. If you have any questions, please feel free to contact your local Akrometrix representative or visit the Akrometrix website at www.akrometrix.com.